going on YouTube. So the net present value profile is just basically a graph that shows the relationship between the discount rate being the firm's cost of capital and the net present value. So that being said, it is extremely useful because the internal rate of return is defined as where the net present value is equal to zero, and it allows you to visually see that. And it also allows you to visually see, for example, if you might have a situation where there are two internal rate of returns, or if the net present value is positive for all discount rates, you can see this. So to start with, I'm going to just type 1. It's currently formatted as percentage, so I can just type 1 for now, but make sure it's formatted as percentage equals the cell above it plus 0.01, which gives me 2%. I can get this to drag it down. Now for this situation, I'm only going to go to 30. And the reason why I'm going to go to 30 is plus like 100 is because a lot of times the internal rate of return is relatively low. In a lot of situations, maybe 4 or 5%. And if you go to 100, seeing that on a graph can be a little bit tricky. So next, to calculate the NPV, we're going to do equals NPV. The rate is just going to be the discount rate to the left. And as far as values are concerned, so the net present value function in Excel makes it to where you first have to grab the series of outflows in the function, and then you have to grab the series of inflows in the function, and then add the initial outflow or outflows at the end. It's just the way that the function works in Excel. Now, this is not the same for the XNPV function, because with the XNPV function, you can just grab the cash flows. With the NPV function, you have to grab the inflows and then add the outflows at the end. So get that, and then add the $5,000 outflow. As you can see, the net present value at 1% is $355. So next, what we're going to do is going to make sure that we lock the cash flows in place. So function F4 or F4. I'm on a laptop, so it's function F4. And by doing this, whenever we drag this formula down, it will make sure that the discount rate is the only thing that changes. And by having these dollar signs around before the column and the row, it makes sure that the cash flows remain constant. So we're going to get this, Control C, Shift down arrow, then Control V. So just copy and paste it. As you can see, here are these net present value for these different discount rates. Now, to make a graph, all you have to do is just highlight this. You insert scatter and choose an option with a line. We're going to Control X and then Control V real quick, just move it up a little bit. And here you can see here is the net present value pro. And to kind of show you that this kind of goes with IRR, so we're going to have the IRR right here and equals IRR. Now, with IRR, the only function in Excel, you only need to grab the cash flows. And you can grab all the cash flows with the IRR function. And there is the optional argument that is called guess, which is in brackets. And is only useful because the IRR function works, because it does a bunch of iterations to come up with the IRR. And sometimes you have situations where the situation at hand is very complex. So you have to kind of guess to see where the IRR will be to reduce the number of iterations that it has to do. Also, it's extremely beneficial because sometimes you have situations where you have two IRRs, and that makes it to where you can kind of try to make it to where it will select one IRR as opposed to another. So as you can see, it is 2.58%. And to change I just clicked right here to change the decimals that are shown. So, and to kind of show you the benefits of the net present value profile, here you can see another situation where we have some cash flows, net present value profile. And as you can see, here you can visually see there are two values where there is an internal rate of return in the net present value profile. Also, you can see sensitivity analysis, so you can see if if discount rate goes from 10% to 15%, the IRR changes, like the net present value changes like so. Is extremely beneficial too because sometimes there are situations where you have a net present value that is positive at all discount rates. So for example, just changing this to 50,000, as you can see, the IRR jumps to 64%. Um, as you can see, if I change it to 500 to 500,000, as you can see, the IRR jumps dramatically. Um, and let's just say this golf outflow is only $50 instead. As you can see, the IRA just continuing to jump, and effectively it is positive at all values from 0 to 100%. Um, and as you can tell, this is a very weird value that your boss might question. So, with that being said, this allows you to visually kind of see, hey, this doesn't really cross the x-axis between 0 and 100%. Um, That being said, I really hope that this was of use. Please like, subscribe, comment. Let me know. Every like and subscription is a huge, huge, huge help. And please watch the video that's on your screen right now. I hope you like it. And let me know if you have any questions. Thank you.